Well, hello everyone. Look at what I've done. I've gone and cleaned my desk. Now, the rest of the room is a bit of a don't look at that. Don't look at that. Just focus on the nice clean desk and all of the nice projects I can get done on this nice clean desk. So, what shall the first project be? Well, I'm glad you asked. 'Cause I've got one of these. Oh, yes, an official Trampa VESC 100, 250, 100 volts, 250 amps continuous. Yes. Oh, what fun I can get up to with this guy. And alongside with this, I've also got, as you probably saw, ta-da! A big honkin' Outrunner DC brushless motor by FREERCHOBBY.com or .cc, I guess is their website. Big honkin', it's 120 millimeter by 100 millimeter, 100 volt, 250 amp, just like this brushless motor. I got 80 kV with the sensors, which is, you know, one of the best mixes you can have with this thing. I mean, I know this guy's so super smart, you can basically run it without any sensors and it'll be able to keep track of it anyway. But I got it just because, you know, it was an extra, you know, 10 bucks on a $400-ish motor. Yeah. And this is the $700 speed controller, Canadian that is. I didn't want to spend $700 on the speed controller. In fact, I bought the much cheaper $400 version off AliExpress from FreeRC. Not FreeRC. From FlipSky. FlipSky, yes, those guys that make VESC versions of their own. And yeah, that's how that went after a few tries. So yeah, that's we'll not talk about that tomorrow unless you want me to. I'll do that, you know, if people want to learn the story about that. I probably should share that story. It's a good learning experience. But anyway, that's in the past. I've now spent all my money on this. Well, not all of it, but you know, more than I wanted to, more than I should have on this. But I have it, and I have this, and there's just so much trouble you can get up to with this. But not only that, I've not only got this, but of course I've also got, ta-da! Batteries. Lots and lots and lots and lots and lots of batteries. Don't look that way. Don't look that way too long. That way is not safe. Focus on here. Here is where all sorts of wonderful batteries, lithium-ion batteries of all shapes and sizes, most of which with measurements, some of which in cradles already with BMSs, not yet finished, but batteries and batteries and batteries galore, all of which are from drill battery packs, such as this guy. Yes, red lithium, high demand 9.0, and this guy, which is another Milwaukee, just missing its casing, but with the LG browns, with more of these guys in them, and lots and lots and lots of batteries. About 400 cells to be specific. I mean, a bit more or less. I don't know. The counts are just kind of always changing because I keep getting more, and I keep like eliminating some others, realizing that like, oh hey, I can move it. But yes, around 400 cells. 400 cells of high capacity, high discharge. Like literally, everything here is 3,000 milliamp hour or more, and then here it's 2,500 milliamp hour. It's ridiculous. These are all really nice. And you can see, like, these are rated 4,000 milliamp hour cells. This cell right here, 3765 milliamp hour. Like, these are in good friggin' shape. And I've been just collecting them over years, going to my local tool repair center and picking these up for $1 a pound. Can you believe that? $1 a pound I pay for these. Just going to the place that repairs tools, and any ones that don't make it for warranty, I get them, and I take them apart, and yeah, there's just lots of friggin' batteries in there. You see I got some Samsung Pinkies. That's those ones there, 30 amp, 3 amp hour. These ones actually, like, they really recover nicely. They typically have like higher measurements than these guys, even though they're rated at lower current. They perform a bit better as long as you don't pull too much current from them. They're only 15 amp, but these are 20. But yeah, look at all that. Now, what sort of mess am I going to get myself into? Well, I don't have much to show for the final product just yet, but essentially, this is going to power a boat. This is going to power. I'm going to basically be taking the power head off of an outboard motor and putting this on there. And then this will have 3-phase wires plus the sensor and maybe some other control wires coming down from it down to a box that contains all this. And I've actually got that box. The box is actually something I've been working on really hard lately. And so I'm going to show that to you now. So if you give me a second. Ta-da! Look, it doesn't even fit on my desk. But yeah, this is a nice and big Pelican. I think it says on the label here. Hold on, I gotta fucking... Yeah, Pelican Storm Case IM 2500 Pelican. Yeah, this thing I got at Princess Auto for $70, which was a hell of a deal, especially since it comes with, you know, the locking latches, the vent carrying handle, but extra, it came with this nice beefy connector. I'll get to these later. It came with this already installed, this nice beefy housing for a connector, water sealed with a grommet. I'll get to that later. And it even came with the luggage handle. Just fucking up it goes, and there it is, and it's on wheels, so you can wheel it around no matter how heavy it gets with all the friggin' batteries I plan on putting in there. And yeah, now you may have seen the inside and said, well, that doesn't look like there's a lot of work going on. Well, trust me, there is. There's a lot of work going on here because it's all just been in planning phases. Hold on, this shit barely fits on my desk. It really just barely fits on my desk. I've been mainly working on this on the floor, even though the floor has no room. But yeah, you can see the big empty spot where it was. Anyway, don't look at that. But yeah, so this is the big thing. And most of the work I've been doing is concentrated on this side with these lots of big friggin' wires coming out. These are all 12 gauge. These are 14 gauge and all these friggin' screws and stuff to right here where I've got the connector that I have custom made my own connections for. And if you're familiar with these are Anderson power poles, and these are rated 45 amps per pole. I mean, that's with 10 gauge wire, but you know, 12 gauge, 10 gauge, it's, you know, over short runs it's not too bad. But yeah, each of these are rated 45 amps, and I've got 16 of them there, which means, let's see, 45 times 16, that's, let's see, 16, that'd be close to 800, no, not 800, close to, 16 times 6, It's a lot of current, a lot of stinking current can go through there. I had the math done with when I had 20 there. When I had 20 there, it was 900. So 16 would, I guess, yeah, 800, 750-ish, around there. A lot of amps, a lot of amps. And this is the connector that'll go from the VESC here, which is going to go inside of here. I'm going to mount it right up around there. Actually, I'm going to mount it like upside down, just because then it keeps the connectors in a convenient. It's all part of the plan. It's going to mount right there. It's actually going to have a hole cut out of it with, give me a sec, with a heatsink, just like this one, except bigger. It's going to have a hole cut out of there with this heatsink on the other side, so that this thing bonds right to the heatsink. The heatsink will be sealed around the edges of this thing, and that'll just be mounted right there with the heatsink poking out the top, so that'll be there. And then the 3-phase wires will go to this bundle of wire, and you can see I've got 3 rows of poles there. Those will be the 3 phases, A, B, and C. And then these will be auxiliary power. And so these cables will connect up to there. I've got them cut nice and long just because I wanted to get the cable connector done, and I just wanted to have enough to just go wherever I needed inside this box. And they'll go there, and then the mating connector for that, give me a sec, is right over here. And look at this chonker. Look at this beautiful chonker with its 6-gauge wires and sense connector and big friggin' cable gland and big nice plastic. Can you believe that this housing, buying it brand new, was only $9 plus the gland? So like this was like $7.80 Canadian, that is, and then like 75 cents for this cable gland, and just like I couldn't even print it for that. But what I did print is the adapter in there that goes from the housing to these Anderson power poles. And this goes over here, and it plugs in, hold on, around like this. And so you just line up all the power poles, and it sits in. Gotta brace myself a bit, because as you can imagine, this much current requires a bit of force to plug in. It's better when I have a free hand. There. Didn't really make a satisfying sound, but when you get it in nice, it's good. But then it's got this latch here that locks it right in place. And that's just a super sturdy, nice connection. So we got quadruple 12-gauge wires. That's equivalent to 6-gauge, so I've got them crimped on ABC to 6-gauge welding cable right here. This is all silicone cable. I'm gonna have to like put some glue in there and a big piece of heat shrink to actually make this seal, because right now it's the water can get in all the gaps and everything. But yeah, and so that is my custom made connector here. And yeah, it's also really hard to pull off. Like, not so much when you've got, again, 2 hands, but I'm trying to hold the fucking camera. There we go. But yeah, with a 3D printed mount to connect the housing to these Anderson power poles. There's screws going through it in the part where the roll pins usually go. And you notice these parts right here, that's actually for the sense wires, which is coming through this shielded cable right here, going down in through there again, and it's gonna come right out there. In fact, I've even got, if you bear with me, yeah, here we are. There. So this is the same connector as that sense one right there. Same pitch and everything, and it's just gonna go right in the mating connector right there. I just gotta, cut the actual remaining 3D printing bits of the hole, but it just Hold on, let me actually see with my eyes. Come on. Come on. Come on. And okay, I gotta actually poke the hole through that. But yeah, this thing fits right in there. And the mating connector will be on this side, right there. And that'll be the sense feedback. And I'll probably even have the other one here for like the actual throttle and everything. I mean, right now I think I'm just gonna go with like an actual RC remote control going to the PPM input of this thing. But yeah, and this thing is just gonna be cram-packed with all them batteries. You remember that, you'll recall that battery pack thing I had. I'll get it right here. Yeah. There, this is one of the 20 battery packs that I'm going to fit in this case. One there, and if you'll bear with me a second again. Ta-da! So this is that battery pack you saw, and then these are all prototypes of the cradles that hold these. I go through a lot of revisions, but some of these are final, some of these are just, you know, some of them are early revisions, not quite right. Fitment didn't quite work out. You know, the size is just slightly different on some of these, but for the most part, this is going to be the layout. So there's 3, 2, 2, 3, so that's 10. 10 of these packs of 20 cells each. On the bottom layer, there's going to be a second layer, which will come up to there, and it'll leave just enough room for this guy at the top, with enough room right here, in this square right here, for the circuit breakers and the charge controllers and the friggin' all sorts of other stuff that I'll need to make this a working battery pack. And by the way, speaking of charging, these guys right here, these guys are some 14 gauge silicone wires. There's 4 there, and there's going to be another 4 coming out here. And they're going to be coming out around here through this, you know, waterproof, water sealing heat shrink. And they're going to be able to wrap around these guys. So you can just go and wrap them around. And these will connect to some MC4 solar charge connectors right here. Which means this thing will also be solar powered. So, you go out camping or whatever, and you're on the lake, and you reach your destination, you set up camp, you just set up some solar panels on the thing, you hook them up to the battery pack directly with the charge controllers, and it'll charge the battery while you're just leaving it out in the middle of the lake, getting all kinds of sunshine. I've got 400 watt panels, which with the 400 cells, I'm hoping to get 4 kilowatt hours. And so 400 watts of panels, 4 kilowatt hours. And now, you know, you can't assume 100% efficiency, so I'm assuming 50% efficiency. So half of that, 200 watts of efficiency of power coming in. So that'll be just 20, let's round it up, 24 hours of sunlight will fully charge this whole battery pack. Now, runtime, I have absolutely no meaningful way of calculating that. There are just so many variables, so many different things with like how loaded the boat is, how much, whether or not you get on plane, how quickly you get on plane, how many people are in the boat, the gear, etc., etc. There's just no way for me to meaningfully calculate that with all the other variables of like how efficient the motor is, how well like the propeller pitches, whether or not get the gear ratios. There'll be so much experiment to do. There's just no meaningful way I can predict how far it'll go. I'm hoping I get a few kilometers of range, because I go camping and I happen to camp at a place that's 5 kilometers from the nearest boat launch. So if I get 5 kilometers, that'd be great. I've got some data that would suggest that I might be able to get 20 kilometers from this box, which would be amazing. But other than that, I've got very little I can really say in terms of like what this thing will actually be capable of, except that it'll be freaking nuts. And yeah, this is the biggest project I've ever really undertaken. I mean, I've done battery stuff and some speed control, some ESC, some vehicle stuff. I've made I've modified electric scooters and stuff with the VESCs before, and they've all gone pretty well. But this is a few more levels up from what I normally do, and yeah, there's a lot of exciting things that I've got planned. A lot of really, minute details I put a lot of work into, like the fitment of these connectors together to get these Anderson power poles to connect together nicely to adapt to these housings, and to just make a perfect click in and click out, and have it not be absolutely impossible to plug in and unplug, even though it seemed pretty difficult. Trust me, it's not that difficult when this thing's full of batteries anchored down, and you got you can grab this properly, not with your offhand, and it's nice. It's nice, trust me, it's nice. And yeah, it's gonna be something wild. So I'll probably make some more videos going into more detail about some of the different things, like these battery cradles that I 3D printed myself. I mean, there's my Prusa Mini printing off some more for me, and I designed these myself in SolidWorks, and they've got the BMSs kind of at the ready. These are 5-cell BMSs. Yeah, all these packs, they're 4 parallel 5 series, and so these are all 5-cell packs, and there's going to be 20 of them. There's going to be 4 in series to make 20 cell series, so it'll be 72 volt nominal, and 84 volt peak, 60 volt min, and yeah, just some crazy shit. So I'll go in more detail on some of these other things on some other videos. I'll see what the response is for this video, see what people say, see what people want to see more of, and yeah, hope you like seeing this video. Hope you stick around for more. Alright, see ya. Have a good one.